Welcome to Pavithra Laptop Care. Hmm? Today's topic. So later I'll tell you that. So first introduction I'll give you. See, this is the motherboard. Hmm?
Yes.
How many components you are able to see? Here is the IC. This also kind of IC. Hmm? This processor also one kind of IC. Coil. Hmm? These all are ICs, right? This also IC, and here positive components, capacitors, resistors, coil. Okay, we are seeing only positive and active components. ICs are giving the signals, right? Only using the signal, so you are able to run the laptop or not. That the topic actually today. So that I'll ask a few questions to you. So just give the answer. See, I'll tell you. Just already I already explained you. So many signals we are getting from IO and PCH and these processors. Just you think. Just one example I'll give you. See, first class is circuit, right? This is the circuit. Here is the positive and negative. This is voltage 19.5. This is load. If I give the supply to load, it gives the appropriate output. Right. For example, if I give bulb as a load, what it will give? If I give the supply, it glow. Right. Immediately. Consider it as a switch. If you turn on, immediately light will come. If you remove, it will be off. Just assume a question to you. If this load is a laptop motherboard, okay, just assume it's a load as a laptop motherboard. Directly you are giving supply. What it will do?
On.
Direct on. Here directly it will on laptop. If you turn on this button, immediately it will on like a bulb. Will it give any decision? Just it will glow. Just it comes display. It won't do anything. Immediate display will come. Just assumption I'm telling. Right?
Since it is open, it's not open.
If it is a close, immediately this bulb will glow. If this load, consider it as a laptop motherboard, what it will do directly, it gives from display or direct this one display. Just you think about it. Why it immediately it won't turn on? Why you required it's a power button, and after that so many process, and after that finally you will get the result, right? So why it required? See, directly if you give the supply, the what are the coil output voltages we will get, no? All voltage we will get, okay? Directly we will give to the PCH or processor, whatever it may be. So directly it gives the output. But in motherboard they not did like this, okay?
One by one.
What it call actually? They not did like this, right?
Closed circuit. Open circuit.
No, these are closed circuit only. But see, first you connect the adapter. The voltage comes to the particular circuits, right? After that, it won't turn on immediately. If you press the power button, then also it won't turn on immediately. After some time, it will start, right? Why these all are the time delay and what it causes actually?
Any short circuit? No.
See, one thing I'll tell you, 99.9% technicians are there in the world. 100%, almost 99.9%, they won't know about the name of this process. These all are called decision making circuits. Decision making circuits. Okay, decision making in the sense yes or no, yes or no, that is a decision, right? See, you are coming from Yelahanka to Chandapura, right? You are coming by bike. If you take directly bike and come here, so you won't reach Chandapura, because first you have to take a decision, petrol is there or not, vehicle condition is good or not.
Confirm.
If you confirmed, then only you will reach the Chandapura, right? Petrol should be there, engine should be, working condition should be pakka, and tire also will be good. Everything you will check first before coming to Chandapura. This bike is like a signal
Yes.
from processor, from engine, okay? It gives the appropriate signal, but that signal has to carry to destination part is
Chandra.
there or not, how to reach that destination part, those things we have to take the decision, right?
Yeah.
Those decision will take the circuits. These circuits is called logic circuits. I already made a video about logic circuits. What are those?
One object.
What are those logic circuits? Logic gates.
Logic, three gates. AND gate. OR
Only
gate.
everyone knows and or not, nor,
Ignore.
XOR, XNOR, and so on. But other than this, some more decision making circuits are there. Everyone knows that, but the name is entirely different. What I told, 99.9% technicians won't be knowing the particular name, because see, this circuit made by engineers,
Yes.
okay, those all are having their own creativity mind and they made this one. Those things we have to understand, and then only we have to do the service things, okay? Before doing service, so technically, once again I am telling you, the word is technically we have to understand what we are going to do, right? See, one most important one example I'll give. In previous video I have done the PSID chapter, right? PSID. In this only I'll tell you one example. This is the positive. Just assume this is a positive and this one is the negative, and here is the ID path. Okay. This one, this circuit is entirely different. This ID path will come through the coil, and here is a MOSFET. There is a MOSFET. Just I'll mention like this, and here is the what is that? Drain, source, gate. Right. Here it goes to IO. Just one simple circuit. Anybody observed what is there behind to this? I mean, below of this, what is there actually?
Okay.
What will be there? I mean, what was there in that circuit? Usually, what will be there?
Three-leg MOSFET.
What is that? MOSFET or transistor? What the component name? Transistor or MOSFET or which one? Transistor. Right.
Switching.
Here transistor
Switching.
is connected here. Here is a what?
Line divider.
Voltage divider circuit. Through this voltage divider circuit, voltage goes to this transistor, and here one what is that? 5 volts supply will be there. Anybody knows why this structure has given here? Directly they have to give to this MOSFET, and directly it goes to IO, right? They not made like that. Engineers not made like that directly. Okay. First, they will think more. Okay, what are the decision manually? What we are doing like that? That system also has to take. Right. See here. This is the Dell adapter. In between, ID is there. Outside of that ID, what will be there? 19 volts will be there. Just assume some kids will be there at home, right? They will do like this. Once it gets short, same adapter they will insert to the motherboard. Sometimes up to one level it will reach inside. After that, the middle point will get cut. It will join to the 19 volt supply. Then what will happen? Here 19 volts will come here, right? What will happen if suppose this circuit is not there, directly drain to source it will pass. Then it will damage the IO. IO only works through 3 volts supply.
Okay.
not 19 volt
Right.
supply, right? Once it goes to 19 volts, definitely IO will get burned. So they also thinking logically.
Okay.
See, just assume this circuit is not there, then it will damage the
IO.
motherboard. Right. So the circuit engineer, what they are made, no, those people will think like this. Small also they will think, and they will made a decision making circuit here. Orally we can take decision, but those electronic component won't take decision, right? That's why the particular where exactly the circuit, what is that, how they design, right? See, particular decision where it has to take and what component has to take, that first they will think and they put the particular places. Then only this. Okay. See, then only this decision will happen. Just now you assume this one is connected now. So what I told, 19 volts is short here. Then what it will come here, high voltage will come, right? Here it's more than 5 volts will come in the V out.
Yes.
Then what it will do, it will be on condition, and what are the voltage it going here MOSFET, it will get cut off, it goes to the ground, right? This 5 volts goes to the ground, then it will be in off condition, then circuit will be protect. Here is the logic, right? So these all are called decision making circuits. Decision making circuit. We know this. These are transistor is there, but what we are doing, just we have to remove this and we have to give directly jumper or so many things we are doing. Those all are wrong things actually. First we come to know what it is and why they are given here. Okay. Now understood, right? So simply without knowing, please don't remove any components. Technically you have to understand what component it is and why they are given their particular places. Here the transistor uses cut off this particular MOSFET. So here is the logic decision it taken,
Yes.
right? Here high voltage comes, then it will be cut off. Then it protects the circuits. Here is the one logic decision taken. Like that. Have you seen the first MOSFET and second MOSFET?
Yes, sir.
Gate, right?
Yes.
Directly 19 volts will come here. It's a drain. Here source. Again it's a source and drain. Right. Just I am taking example of gate.
Yes.
In many diagram you have seen two transistor will be there.
Yes.
PNP
And NP.
and NPN. What is the use of this?
Switching mode. Yes. Logic switching.
So logically it will cut off the supply here. It won't allow the 19 volts to CLR path. You have seen, right? Two transistors. Because how it will take decision is, see, here is the collector base emitter. If any voltage that off, what is that, power off something, AC off, one signal will come here, right? AC off simply it won't come. When any damage occurs in the motherboard, that time it sends the it sends first and it detects the particular damaged things, then IO will release the AC off signal. When AC off signal will come, this will be active and it will ground the particular supply. Like that, some logic will be there. It won't allow 19 volts to CLR. Once it allows the 19 volts here, the motherboard may get damaged. To avoid those things, here a technology has given here.
Yes.
Decision making circuits. See, today's topic is decision making circuit. Decision making circuits. In decision making circuits, there are majorly two technologies are there. One is TTL.
TTL.
I already explained in a video.
Yes.
In logic high-low, what is it, pull up and pull down register, I think so. That video I already mentioned. Second one is CMOS. What is this TTL? Anybody explain? Anyone can tell?
TTL.
Can you tell anyone?
Transistor logic.
Correct. You are in this industry, no? That's why you know that.
Yes.
Transistor,
Two transistor logic.
transistor, logic. So this is called logic. You know only these logic gates. Other than that, these logics also used here.
Use it. Yes.
Okay. Transistor to transistor. Just now I explained you.
NP, PNP. Yes.
This is transistor to transistor.
Yes.
Here it's actually these are switching circuits.
Yes.
Switching circuits is nothing but
Yes, sir.
decision making
Decision
circuits. If switching circuits won't be there, definitely your motherboard will get damaged. More damage, not only a small one, more damage. It avoids the more damages. Okay, please don't ignore these switching circuits. Many people are ignoring and removing this one directly. What they are thinking, just motherboard has to be on, that's it. They have to do normal work and what is that, once is switch on, they will give to customer. Please don't do that. Switching circuit also very very important once this condition is applied. So customer has to pay more money for the motherboard in future. So please avoid those things. You will get anyway, you will get the service charges, but damage may happen in future days. So that's why keep it in those things. So place the particular MOSFETs, sorry, transistors, MOSFETs or transistor, whatever it may be, don't remove, replace it.
Immediately replace.
Okay, see, this is called TTL.
Yes.
And one more is there. This is, what is this?
CMOS. Counts.
What is
Metal
it?
oxide semiconductor.
What about C?
Complex metal oxide.
Complementary metal oxide semiconductor. Okay, complementary metal oxide semiconductor. You know what about this?
Is active components. Is IO and
This one used only MOSFETs. Just I told you TTL how they are using like a switching circuit. This is also switching circuit.
Same.
Here they are using MOSFETs. Here they are using transistors. Transistors. Here I told you this is the transistor. MOSFETs. Here I told you. Here actually see transistor is there. Below that one more N channel MOSFETs will be there.
Yes.
Have you observed? These are called CMOS. Okay. In switching circuits, one type is CMOS, other one is TTL. Both are very important. Okay. First, technology you have to understand. In some cases, they are used only TTL because this having low impedance and high speed. That's why these all are used in 19 volt section, almost. 19 volt section, here also 19 volt section, right? PSID. What, just now I explained, here 19 volts comes, this also 19 volt section actually. TTL, just a minute. Okay, see, TTL having low impedance and high speed. This one having high impedance and low speed. So in particular section only these MOSFETs will be used. What are the section? Already you know what it is. Here is a 19. Which section?
I first. I and low.
Which section?
MOSFET.
This is called CMOS technology. Here MOSFET is used as a switch, right? This is switch function it will do and high-low function it will do. Now you understood, right? You are already using this technology but you don't know the name and why they are given here, that you don't know. See, everywhere here only they are used IC, already I told active and passive components only used, but how they are used depends on that this will work. Okay, one is TTL technology, other one is CMOS technology. TTL required only less voltages, maximum 5 volts is more than enough. Here it will work 5 volts, 3 volts to 15 volts. Okay, this small one I am talking about. What is that? Before they given, no? Here. No, here. Okay, it has internally a high impedance, means it required more voltages. So that's why they are not using in
TTL.
these circuits. Here TTL as used because it's a fast switching circuits. Okay. Here high impedance in the sense it required more voltage to on, switch it on. That's why it takes in these functions only they are used. If we give more voltage, the TTL transistor will get burned. So that's why in these sections they are not used.
These are, yes.
Instead of transistor, they use CMOS technology. Understood? Impedance is more, that's why. Speed is low, but the time delay is required here in this particular section. Because first the IC will work, what are the input they want, everything they have to take, then only using the gate it will switch it on, right? So here is the CMOS and there is the TTL. Now you come to know what is TTL and what is CMOS. Like that many technologies are there. DTL, what is this? DTL. In many circuits, many technologies. D means it's a diode. Diode transistor they are used for switching circuits. Once diode is active, then transistor will active or passive like that. Okay. Many are there, but commonly we are using CMOS and TTL. This technology is very simple. Using the positive components, where exactly they have to use depends on that circuit they will use. So that's called, it's a technology, particular name they kept. DTL, TTL, MOSFET and many things are there. Now you understood, right? See, in these technologies, some conditions are there. TTL or CMOS, one common thing I will tell you. Prasanna,
Yes.
see here. One common thing is
Yes.
up to particular voltage 0 to 0.8
Yes.
it will consider as low,
Maximum voltage.
means 0.
Zero.
You know our computer will understand only zeros and ones.
Ones.
The voltage also goes to zeros and ones.
Ones.
These components having this much of voltage, then it will consider as a low.
Low. Yes.
Okay. Here 0.9 to 1.9 or 2.1, okay, will consider as
High.
intermediate, means no result. Right, you already know this one, this condition. See, if your voltage getting, last time we got voltage 1.9, where?
Yes, yes.
Battery section.
Battery section.
Remember? Yes, sir, one, that switching was there, no? When you remove the battery, it was 3.3. When you connected the battery, it was 1.9 volts. But there should be 0. Actually, 0, okay, but up to 1.9, it's intermediate. It won't understand what it is. So, that logic has given there. Now you come to know, right? When you press the switch button, then it goes to 0 or high, anyone. If you release the button, it will be high. If you press the button, it will be goes to low.
Low.
The circuit, that IC, what they will think, if you get this voltage, they can't understand anything.
Anything.
Understood?
Yes.
So ICs are working through the logic gates. They give the signal according to the low or high. If you give this voltage, it won't understand anything. It will be idle position.
Yes.
Okay.
Ideal position.
Huh.
Yes.
Here the battery section, that was idle position because they can't understand what is low or what is high.
Right.
If high means it will provide the circuits. Connection. It gives the circuits. Okay. But when it will be low, it disconnects the circuits.
Low.
Right. And again, it's a 2.22. If you are, I am considering 3.3 volts. 2.2 to 3.3, it will consider as a high.
High.
Means it's a 1. Now you come to know how the manufacturer made this motherboard
Yes.
using
Yes.
active and passive components. See, only simple thing is only active and passive components are there here. Active components give some signals. Passive components will passes the signals. That's it. That pull up resistor is a passive component. But what it passes? It passes the signals. Right. In what condition? These conditions. High-low conditions. Right. In DRM RST, there will be 0. Okay, not DRM RST, just PSID. Just in last video I already explained. If adapter is not good, then low it will pass.
No.
The pull up will be 3.3 volts, but here it will be 0.
Zero.
Right? It makes the ground. Means here low signal will go to IO. Then it takes the decision, it's a unknown.
Yes.
Now you understood, right?
Yes.
So like this, so many logic decision making circuits has used here. You already seen the diagram. So many transistors, many MOSFETs, 3-leg MOSFETs, 6-leg MOSFETs,
Yes.
those all are called decision making circuits. Now you understood, right?
Yes, sir.
So today's topic is over. These all are called decision making circuit, but please give more concentration on decision making circuits, transistors or MOSFETs,
MOSFET.
3-leg MOSFETs especially. I'm telling, many people are removing that. Please replace it.
First replace.
Okay,
Okay.
understood, Prakash?
Okay, sir.
Okay, thank you.